Okay, welcome back, kiddos. Now we are wrapping up Unit 7. So last time we talked about parallelograms. Now we're going to talk about some special parallelograms. Okay, so we talked about rhombuses last time, and we're going to go more in depth about that, but especially rectangles and squares. Okay, so let's get right into it. Okay, so you probably know the basics of what a rectangle is, but let's talk about how you could describe it, right? How would we describe it? We could say it's a parallelogram, right? Parallelogram means both of these are opposite sides of parallel, plus it has all uh, angles are right angles. Okay, so which means they're 90 degrees. So all the angles are right angles. Okay, so we can see this right over here. That symbol, right? That tells us all four are right angles. Okay, now not only are all four right angles, the diagonals are congruent. Diagonals are congruent. Okay, we know congruent means the same length. So diagonal, what we talked about, goes from one corner, right, across to the other corner. Right, so let's go ahead and draw in that diagonal. So if we said that's a diagonal, right? And then if we go from here to here, right, we say that's a diagonal. Okay, the diagonals are congruent. Okay, so say this is that length, right? Then that would be that length. Okay, and that length and that length. So all those, because these are congruent, right? If they cross right over there, then it's going to separate those into two separate parts, right? Because we talked about before, we said the diagonals always bisect each other. Okay, so next, a square. Okay, so a square is a parallelogram, right? Because we know these are parallel, those are parallel, plus all angles are right angles. Okay, and then the last thing is not only are all angles right angles, but all sides are congruent, right? So that means all of these have equal measure, right? And that's how we indicate it, right? That tells us that all four sides are the same. And so that's the difference between a rectangle and a square. On a square, we know that all sides are congruent, right? And then they have four right angles. It has four right angles. Okay, so then on a rhombus, okay, we said the rhombus was all the same. It is a parallelogram, right? This is a parallelogram. That's a parallelogram. That's a parallelogram. Plus all the four sides are congruent, right? We said that's the indicator right there. That's what we talked about. But the angles are not necessarily right angles, right? So we don't know that. That's why this is different. But we can also say these things. The diagonals are perpendicular. Diagonals are perpendicular, and the diagonals bisect at right angles. Okay, so we're not going to talk too much about rhombuses today. We talked about how four sides are congruent. That's the main thing that we need to keep in mind. Square, all sides are congruent. All angles are right angles, and then rectangle is all angles are the right angles, but the diagonals are congruent. Okay, so keeping that in mind, let's get right into some practice. So this is how you might use it in the real world, wherever you live, or maybe for a job, or who knows. Okay, so say you're building a frame for a window. Okay, so a frame is this right over here. Okay, that's the frame for a window. The window to be installed in the opening, it should be installed in this opening. Okay, so the opening has to be a rectangle. Okay, in order for the window to fit, right? Because we need to have it be able to fit in that window, right? So given the measurements, can you assume that it's a rectangle? Okay, so let's look at this right over here, right? So we're asking, is this a rectangle, right? This right over here. Well, what do we know? This is 44, this is 44. This is 33, and that's 33. Is that a rectangle? Many would say yes, But we don't know if that's a right angle or not, right? It could be slanted a little bit, right? It could be off just a little bit like that, right? So the answer is no, because not sure if right angles, right? We don't know if those are right angles or not. If they're right angles, then we could say that they're a rectangle. So you measure the diagonals. The diagonals are 54.8 and 55.3. That means one of these, right, we would say that's like 54.8, right? And then we would say that one is 55.3. Okay, if I told you that, is that enough to say it's a rectangle? What can you conclude? Well, we said the diagonals have to be congruent, right? So those are not equal. They are not congruent. So no, it's not a rectangle because diagonals are not equal in length, right? That means congruent. They're not equal in length. Okay, so that's how we know. So that's how you could if you did your own window, you'd measure that and you'd measure that. If those are both equal, then you know it's what we call square. All right, so keeping that in mind, let's get into a mathematical practice on this. It says in this rectangle, QRST, so it goes QRST. So they're talking about this rectangle. And by them telling us it's a rectangle, then we know that those are right angles, right? Okay. Then it says QS is this, so QS is that diagonal, right? And RT is this. R to T is that. Find the lengths of the diagonals. Okay? They want us to find the length of the diagonal. So if those are represented by that, we need to, number one, we need to, so step one, we need to set up and solve. Okay, and then step two, we need to substitute. Right? Anytime it's something like that and they want to figure out the whole thing, then we have to substitute. All right, so let's do step number one. Okay, we want to set it up. All right, so if they're telling us these are diagonals and it's a rectangle, do they add to something or they equal? That's right, they equal each other, right? So we would say 5x minus 31 equals 2x plus 11, right? Because we would say that QS equals RT, right? That's what we would start with. And so instead of QS, we're going to put that. Instead of RT, we're going to put that. Now that we set it up, let's just solve, right? We're just going to subtract 2x there so I can collect my x's on the left side. 5 minus 2 gives me 3x. Bring down the negative 31. Cancels, bring down the 11, right? Okay, so then you know what to do next. We're going to add 31. Add 31. All right, cancel. 3x equals 42, right? Then divide by 3. That gives us x equals 14, okay? But we're just going to circle that because that's not our answer, right? We need to now go to step number 2. So step 2, we're going to substitute, right? So we said QS is 5x minus 13. So 5x minus 31. 5x minus 31 is the same thing as 5 times our x value of 14, right? That's where we're going to plug in that 14 from right over there, minus 31. Okay, so if we put that on a calculator, that's going to give us the answer of QS equals 39. Okay, now, if this is 39, what would you expect RT to be? 39 or different? We should also expect it to be 39. So let's check our work just to make sure, right? We would say RT is 2x plus 11, which means 2 times 14 plus 11, right? If you put that in a calculator, 2 times 14 is 28 plus 11 gives us 39. So just as we suspected, the answer is 39 on both of those. All right? So that's our practice with those diagonals. All right, so now we're actually done with all of our mathematical stuff for this unit. Now let's just get into some practice on what we know. So we're putting everything together. This is the last thing. Okay, it says, fill in the sentence below with the description that most specifically applies. So the best answer. Best answer. Okay. All right, so let's check this out. What would we call this? Well, let's look at the hints. What do we know? We know that if these are the sides, we could say that all sides are congruent. All right. What else do we know? We know that we have 4 right angles. Okay. So 4 right angles and all sides are congruent means it is a square. Right? That's the best description of that is it is a square. All right, boom, let's keep it moving. What's the difference? Now, this one looks really similar, right? Let's look at this one, though. What do we know? We see these hints. Those tell us what? The sides or the angles? Those are telling us that all sides are congruent. Okay. Now, what do we know about these angles, though? This is the arc. This tells us that's a 2. Okay. And then this has 2. That has 1. That has 1. So are all 4 angles the same or are they different? Okay, so that means that these 2 are different from these 2. They're not all the same. Okay, so the only thing that we know is if all 4 sides are the same, that it is a rhombus. Because it cannot be a square, right? Because we don't know, not 90 degrees, right? So it is a rhombus. Okay? Technically, a square is also a rhombus, but this one doesn't tell us. If we knew that those were 90 degrees, then we could say it's a square, right? All right, let's keep it moving. Let's look at this one. Ooh, what do we know about this? I see that, 90, 90, 90, 90. That means we could also do that, right, to give us an idea, right? So if we said that it has 4 right angles, right? What else do we know? We know that these 2 opposite sides are equal, right? We know these 2 opposite sides are equal, right? So 2 pairs of opposite sides are equal. That means it has to be a rectangle, right? It cannot be a square because not all the same sides, right? Right? So that one has to be, and same thing with the rhombus, right? Same thing. So it has to be a rectangle. All right. Nice. Let's keep it moving. We just got 3 more left to do. All right. Cool. Let's check this one out. What do we know about this? I see that angle, that angle, that angle, that angle. Okay, so no right angles, right? Now, what else do we see? I see this and that. We see 1 pair of parallel sides, right? So it looks like if it just has 1 pair of parallel sides, it can't be a parallelogram, right? Cannot be a parallelogram because only 1 pair of parallel sides, right? So that means it has to be a trapezoid. Okay, it has to be a trapezoid. All right, let's keep it moving. What do we know about this one? Ooh, it looks like it might be a trapezoid, but it has to have these parallel sides to know it's a trapezoid, right? I don't see that there. So let's look at the angles. Those, I have 1 90-degree angle. That's it. So this one actually is not a square, right? It's not a rectangle. Okay, it's not a rhombus because we know the sides are different. We don't know anything about the sides, right? It's not a trapezoid because it has no parallel sides, right? No parallel. So this was what we call just a generic or basic, right? Basic, just the same thing for generic. It's a generic quadrilateral. All right, anything that has 4 sides to it, we know is a quadrilateral. right? So that's just generic quadrilateral. All right, and then our last one. See if you can figure this one out on your own. Let's look at those hints. Okay, so I see this and that. What does that tell us? It tells us those sides are parallel, right? Then what about this? What about this one and this one? Those arrows. Okay, this one has two arrows, right? That means these two are parallel. That has one arrow, that has one arrow. That means those sides are parallel. Okay, so what do we know? We know it has two pairs of parallel sides, right? Two pairs of parallel sides. Okay. Then we see that these angles are the same. Those angles are the same. So we could say it's no right angles, right? So no right angles. As far as what we can tell, we don't know anything about this. So no parallel sides, no right angles. We don't know anything about the sides. We don't know anything about that. No. So the only thing that we can say is that it is a parallelogram. Right? Okay, so we go through the basics of what we know. Okay, so if we know anything about the sides, it might be a square, right? If we know that the sides are congruent. Okay, if it's a rectangle, we know because the opposite sides are equal. But if we don't know anything about the angles, but we do know the sides are the same, it has to be a rhombus, right? If we know one pair of sides are parallel, it has to be a trapezoid. If they're not right angles, right? Because it couldn't be a parallelogram if the other two aren't. If nothing about the sides and nothing about the angles are equal, it has to just be a generic. And then if it has two pairs of parallel sides, it is a parallelogram. All right, so that's it. That's the basics on that. I know you got this. So just let me know if you have any questions that we can work through together. Otherwise, let's make it happen, do that review, and you'll be set for our test.